I am off right now. I'm not working, but I just had to record this. I randomly decided to try to make an operating system. And shh. And we're working on it now. I I want to make it so that you guys can call me an idiot. That's the only reason. So that my legend can grow. So that people can say, Larry is so crazy, he made his own operating system. That's how crazy he is. He has to do everything himself. Plus, I feel like it would, like, even if we don't get it to the point where it's usable, just to know how to do that would be sick. And we could install it on any device maybe, and just make devices do whatever we want, like from nothing. That's pretty crazy. I want to know how to do this. I don't know if that's how this is going to work or not, but I gotta check it out. So, you guys get to join me on this journey. If I could get video games to run on a custom OS, I would have a lot of power for botting, because the OS could trick the game into thinking it's running on Windows, but it's actually my own OS, and I would have complete control of everything, and they would have no way to know. It's not like I'm hacking a program. I am the operating system. I do what I want. Like, I would have all power. I'm not trying to trick Windows into not knowing what's going on or whatever, break into Windows. I would be replacing Windows. I would be Larry O's. Move over, Bill Gates. Someone way better than you just entered the room. Plus, I could create an operating system that's super streamlined and perfected for robotics and like computer vision. It could be like extra fast running and lightweight and stuff. I can do whatever I want. Gosh, I'm excited now. This is going to go along well with my electrical engineering degree that I issued to myself because I felt I deserved it. Hey, yes. I'm tired. I'm very focused. I'm trying to learn something. I'm trying to make my own operating system. It's been a dream of mine. I just figured, why not jump in right now? So now I'm doing it. It's pretty exciting. Thank you for making me an emote. I'd be happy to check it out. That's very nice of you. wow, if I can make my own operating system, I can load it onto a phone and just take over a phone completely from the very ground up. We're talking, I don't need Android, I don't need iOS. I would literally be able to well, if those phones have a BIOS, that is, I would have to disconnect wherever the operating system is and connect some kind of memory device that the phone can attach to. Maybe that's like a ROM chip or something that my operating system would be on? Or a SD card? Yeah, probably SD card, right? And then it would locate that. My bootloader would be in the correct location on the SD card. It would detect it as a bootable disk. It would load in my bootloader, which would then load in my kernel, and my kernel is going to run everything. And from that point over, we have hijacked the phone. We have total control of everything in the phone. Wow. Guys, this is powerful. This takes us down to the deepest depths of total control of a computer, any computer. Thank you, Gaming Galleon. Guys, this is actually so easy, I think. I mean, the way it works. Every computer has a BIOS, and the BIOS loads a bootloader, which I make, and I store on a memory device. And then my bootloader loads in my program, and then it just runs. My program's the operating system. It's that simple. So I get that. We got this, boys. I would like to create a hello world program. So basically, I would put in a floppy disk into a computer with an empty hard drive. Or, no, I could put it into a computer with a hard drive running Windows. But then, when it starts to boot up, you press escape or F2 or whatever to enter into BIOS, and you set the device boot priority to be USB and then hard drive. So it will check the USB first, and it will find a bootable drive on it, and it will load my operating system instead of Windows. But if I unplug the USB, it'd run the normal Windows that's located on the hard drive. So in that way, we can test it on a laptop nearby. And I have laptops around. I have one right there. And it will load up whatever I want and just take over that laptop. And that could be really useful. I mean, that's living the dream. We'd have total control. It's like, rather than create a program that runs on Windows, we could create a program that just runs. Not on Windows, it just literally just has the whole computer at its beck and call. No operating system underneath it. It is the operating system, but it could be a program. It doesn't have to be an operating system with user interface and that runs programs and on and on and on. It could just be my program, just whatever I wanted that computer to do, like a robot's brain. It could be. That's true. I mean, I think, like, when you code a microcontroller, you install the firmware or a bootloader, and then the bootloader will install your Arduino sketch, which basically acts as a kernel. And so, in effect, your Arduino sketch is an operating system then. It actually is an operating system. So I've already been creating operating systems in that regard through the Arduino IDE. But the problem with that is that's just on a microcontroller. What if I want to create an operating system that runs on a phone or actual PC without having the limitations of Windows or something? This would be a real-time operating system. It would run a lot faster. It wouldn't have to wait around as much. It would take complete control of the system. And it'd get rid of the user interface and everything. It could just be lightning fast. Alright, I gotta organize myself now. Let's see. When is Larry OS going to be ready? It'll be a while, I think. Thanks for the donation. I'm giving an operating system tutorial. I can't do dabbing tutorials when I'm already doing another kind of tutorial. That's too many tutorials. That's like tutorialception. I already give up. Oh! Alright guys, I need to let you know what's going on here. This isn't going to be a tutorial after all. Okay. So, I was wondering, can I write my assembly language in dev C++, which is the language I code in normally? Or that's the IDE I code in normally. But it turns out that's an IDE designed to create C and C++ code, not to create assembly code. So for creating assembly code, from what I gather, you just do it in like Notepad, and then you save it as a .asm file, and then you use a program called NASM to compile it into a binary file. And then from there, you you copy the binary file onto your disk, I guess. Using part copy. Which is another software program. So these are non-optional steps. I need to add this to my notes too. So, Okay, so we will literally be coding something in Notepad, saving it as a .asm file, and then using a program called NASM. I believe that's what it's called. Yeah, NASM, which will enable us to convert the .asm file into a .bin file, and then the .bin file we will be able to install onto an empty USB thumb drive, which will cause that thumb drive to become a bootable device, or a boot device. Then we can plug that into any machine and it will recognize it as a boot device, and it will run that bootable code, or that bootloader. And that bootloader can say hello world, and we'll literally have taken control of that computer at that point. Now, the next step would be to have that bootloader interface with the BIOS and get information and set a couple flags, and then it will load our bigger programs, which will have the whole operating system. But the bootloader is the first thing. The bootloader loads the operating system in. So we're going to create our sample bootloader next. This is all simple stuff, but I just wanted to see if I could avoid downloading third-party software. So I didn't want to download NASM, and I didn't want to download part copy. But I don't really see an alternative here. I might be able to find an alternative, maybe. Let's see. Systems are being used? I have no idea. Why do I need my own operating system? I feel it will give me a much deeper understanding of computers, which will help me. So basically, as an educational tool, just making a simple one, just to learn what goes on behind the scenes, which will help me become a better C++ coder at low-level programming. But beyond that, it would give nice insight into learning how to hack Windows, or possibly create my own operating system for like a cell phone hardware. So I can basically take over a cell phone without using, like, imagine if I wanted to make the motherboard of a cell phone into the brains of my robot. Would I want to use Android or iOS? No, imagine all the overhead that has. It would be way too slow if I just made it as a phone app. You would want it to take over completely. And the best way to take over an actual 32-bit processor is to know how to make your own operating system from scratch, rather than try to find an operating system compatible with a mobile platform like that. Now, Windows does have a mobile operating system that will actually work on Snapdragon, which is a cell phone processor, all-in-one processor. So I could just create a desktop application there, but that'd be a lot slower than creating my own operating system as my program, rather than run a program on an operating system. So I could create real-time, much faster, more lightweight solutions that way. Get rid of anything not needed for just real-time data processing, computer vision, whatever. So it actually could come out to benefit me in a big way for robotics, to create my own operating system. Now, most people will just use a lightweight Linux distribution for robotics and then build their program onto Linux. But I'd rather not learn Linux. I'd rather just create my own operating system and program that directly, and not have to deal with even the overhead of Linux and having to learn how to use Linux. I don't even want to learn how to use Linux. Alright, so this is another program option we could use, called bin utils. gnu.org/software/bin-utils. You download the whole utility package. One of the things included in that package is the GNU assembler, which can convert your Notepad assembly file into an object file, which is machine code.
And that object file machine code is then compatible with their linker application, which you use through command line to link a bunch of files together, I guess. I'm going to try to just go with the NASM option rather than have to download a whole utility package. So the tutorial I'm following here on viralpatel.net is actually what I'm going to stick with. I hate downloading extra software programs, but I feel I have no choice because, yeah, there's just not any way around it. Let's see. What the heck? Alright, I'm going to create a new folder, give it the same name. Grr. Alright. Same name folder, now we copy the zipped folder contents into it. Like that. And okay, just making sure. And we can delete the zipped file. Okay, so we got it. Where am I supposed to put this? Hold on. Do you even install it? Okay. Shoot. Okay. I bet it's just gonna open up a command prompt and disappear immediately if I try to open it. Let's just try. We'll double click. Wait, NASM? Run it? Yeah, it just disappears. Okay, that's what I figured. This is gonna be interesting. Okay, I think I know what to do. Desktop, public software projects, RPiRobot OS. We'll stick it in there since it's important for being able to basically compile our bootloader for our OS, which is part of the OS. Okay. So that's done. Where were we? Alternatively, it would be possible to use what was that thing called? Oh no. Here. GNU assembler in Utils. GNU assembler JS. I'm not even writing this in here. Give me a break, man. We'll just have to hope NASM survives the test of time. Where even am I? Getting lost. Here we go. Okay, okay. From there we'll use yet another software program called Part Copy. Which will enable us to copy our bin file onto our USB thumb drive, thereby moving our bootloader to a thumb drive, which we can then boot from our target laptop. This will enable us to hello world our operating system. Okay. And I want to add this note. Note that the dot bin file created by NASM will be around .512 bytes. Which is dictated by our assembly code. And that is the max size that the BIOS will read in for our mbr This is read in as a single image grab by the BIOS, which we cannot control. And that little stub of a program is not big enough to run all of the code our bootloader needs to run prior to launching the kernel. So we then have to run a second bootloader, which the first bootloader will load in and jump to. This bootloader will perform the rest of the prep work and environment variables settings, and then load in the kernel for us. The second bootloader in question that loads the kernel can be up to in size. Which is a lot more reasonable size to work with. Because this bootloader approach has two stages, we call the first boot 0 and the second boot 1, and this is known as a multi-stage bootloader. I'm having to remember like a book and like 4 tutorials and how they all interconnect, and remember where I read everything in order to create thorough notes covering all this stuff. It's ridiculous. I'm taking this out. Okay. Note that our USB thumb drive is FAT32. And when Windows formats a USB by default, it treats it like a hard drive with a single partition and marks it as a bootable hard drive and has a bootloader pre-installed. So when we go to run our laptop with our USB plugged in and set as the first boot device, the BIOS will first see the bootloader default bootloader that Windows put onto our device, and it will see the bootloader flags and it will then scoop up whatever file fills the first doesn't sound right at all. Ah, that guy's full of crap. part copy will put our .bin assembly language file at the root of our USB drive, and it's .510 and .511 bytes will read 0x55 and 0xAA, which will tell the BIOS that oh, never mind. No, I know what's going to happen. Okay. Note that our USB thumb drive is FAT32, and when Windows formats a USB by default, it treats it like a hard drive with a single partition and marks it as a bootable hard drive, and has a bootloader pre-installed who has its 510 and 511 bytes flagged with 0x55 and 0xAA, which tells the BIOS that it is a bootable device, and the BIOS copies in the first 512 bytes section of that bootloader and runs it on the processor, and that, again, coded by Windows, will then jump to our .bin file bootloader that Windows code will detect in the USB device's memory, and it will copy that bin file as a 512 byte image. No. Use an assembly command to jump to the location in memory of that no. Wait. Dang it. There we go. gotta locate any files located on itself that are around 512 bytes long and have the 0x55 and 0xAA flags indicating it is a bootloader file, and it will copy that bootloader file to memory address and it will jump to that address and execute from there. And at that point, the processor will be executing our bootloader that we wrote in assembly and converted to a bin file with NASM and copied to our USB with part copy. Program. Note that whether we were using a floppy drive or a FAT12 or a FAT32, regardless of that, Windows would have its bootloader sort all of that out and load and run our bootloader, which we put on that drive for us when we go to run the drive in BIOS. Escapade, what the heck are you talking about? Are you some kind of operating system coder? Why are you asking that? Are you familiar with NASM? Do you code in assembly? I thought that I'm writing things that nobody would know what I'm talking about. This is all my notes so far. I got like 3 pages. Okay. So, I'm trying to create my own operating system. I try not to copy paste too much because I want to learn more. Okay. We need part copy now. What did you do 10 years ago? You wrote an operating system? Okay, so now it's unzipped. Let me just save a local copy in 2 spots. I want it in my general software folder that I keep on a separate hard drive than my operating system. And I also want it. What? Oh, no. Okay. I copied a copy of it into one of my personal folders where I keep all my software copies, and then I put it also in my ARPARobot OS folder. So now we've got the 2 utility programs that are musts. This part copy program is what puts our bootloader.bin file onto the USB. I don't know why we can't just copy it with Explorer. They said you need a program to do it, so I don't really get that, but okay. Probably because of where it stores it in the memory space, it has to be a certain spot on the USB, and if you used Windows Explorer to copy paste it in, it would not be in the correct spot in memory on the USB, I guess. But part copy will put it in the right spot for us, I guess. And then NASM, which will convert our .asm file into a .bin file for us. So those are our 2 utilities that we need. Can't do this without it. Unless we found alternatives, and there are alternatives. As a student, you had to do C programming. Why would you need to learn about NASM, though? I don't want a new version. I want the version that my tutorial has. Alright. This is our sample bootloader. It's just gonna do nothing. I'd like it to like say hello world or something, but they're making me do nothing with it. I kind of don't like that example, but well. Actually, I have another tutorial I could probably mix into this tutorial if I want to write something to the screen. That'd be pretty cool. I don't know if I can though, but I'll try. Maybe. Alright, you gotta click on all files. For Notepad. And then we're gonna call it my bootloader. Actually, bootloader.asm. Okay. Alright, so a semicolon means comment. Tell the assembler. I don't. Oh. Okay, so I'm guessing NASM is our assembler. Even though this file is called a .asm file, it's plain text. Just like we create a file called .cpp, it's just plain text. It's not yet converted. Our compiler converts it. So NASM is our compiler, or aka assembler. Compiling puts together libraries and headers, and then sends it to an assembler, and then from there it goes to a linker, I guess. There's like a tool chain that's behind the scenes in your IDE, which I'm not really that familiar with. So we're kind of having to create our own tool chain with no IDE here. So bit 16 is set first. And then, as per our notes, that has to do with us coding in... Wait, did I even write notes on that? Yeah, I did. It's called real mode or real address mode. And that's always 16-bit. Protected mode, which is what our kernel will run in, is in 32-bit mode. So, and also, bit 16 is a throwback to the very first IBM computer, and it's all legacy. So, real mode refers to that legacy situation that used 16 bits, so that's why you still use 16 bits in assembly at the very beginning, because that was how it was done old school. As per this book I had to read, it's not really a book, Project 4, Writing a Bootloader from Scratch on cs.cmu.edu. I should maybe put some resources in my notes. Has good guide on making bootloader overview. And some history behind it. Okay. Great overview of what happens during boot sequence that loads your operating system. Full walkthrough of creating your first basic operating system. Amazing tutorial on creating your first bootloader. Alright, so those are my references. And let's continue our tutorial. So we just copy pasted all of this in a notepad. We saved it as a .asm. Alright, org07c00 origin tells the assembler where the code will be in memory after it's been loaded. Okay. Sounds good. The BIOS sticks our bootloader code in that memory location. So we set that memory location as our starting point in our code as a reference point. Okay. Jump money, infinite loop. Jump at location, $ means jumping to the same location, thus nothing but an infinite loop. We just want to hang our code here. That's crazy you guys created a simple operating system for a C class. That's so overkill. What a thorough teacher. I don't think most teachers teach that, for crying out loud. Okay. Okay. Beautiful. This is a really, really good tutorial. I've never coded in assembly before. I guess you could say I'm not even coding it now, but I mean, I copy pasted all the notes and the code, so I guess I'm kind of doing it. Okay, now this part, you can't just type NASA and blah blah blah. I don't think that's gonna work. We have to put the full system path. Actually, I consider creating my own operating system to be step one to making a robot. Because the best operating system for a robot would be making your own. If the robot's brain is the operating system rather than a program written on top of an operating system, would it not be all the faster if it directly interfaces with all the hardware rather than talking to an operating system for permission to do so? It cuts out the middleman. I think it's better.
Our code will be created in Notepad and saved as .asm file type. And the code is below. And now we need to run NASM to compile that code into a .bin file. And we do so by opening the command prompt and pasting in the following command. Alright, so we include the entire path: F drive, desktop, public software projects, Art by Robot OS, NASM 0.98.35-Win32 / NASM.exe space bootloader.asm space -f bin space -0 boot.bin. So, oh, do we need to? We got to put the full path of this too before bootloader. F drive, desktop, public software projects, Art by Robot OS, bootloader.asm -f bin -0 boot.bin. We'll use the whole path before that too, I believe. Okay, so that's super long command. But we're explicitly saying where each file needs to be, rather than setting a system path variable or something, or or whatever, which is like CD and whatever else. Okay, where's command prompt? Accessories, command prompt. Okay. Oh no, we can't paste it? Oh, you gotta be kidding me. Wait, you can paste it, right? Edit, paste. Okay. F drive, desktop, public is not recognized as an internal or external command. Oh, how do you put spaces then? What? I think you need to put it in quotes then, if you have any spaces. Yeah, it's gotta be, right? Yeah, it's gotta be. I'm pretty sure. This is so long. Okay, so first we have the executable, then we have the name of the bootloader.asm, then we have an indication -f bin, and then we have -f or -0 -o, and then we have the full path of the bin file we want it to produce. Let's hope this will work. Edit, paste. It didn't do anything. But I bet it might have made the file though. It made it. Oh, it made the file. It made it! It worked! That stupid long command worked, guys. Oh my goodness. Look at that command. That is so long. But I did it. In the tutorial, they made it look so easy. This is the tutorial command. I don't know. What is this relative to? You'd have to, how can you just say nasm randomly? You know what I mean? It's supposed to be nasm.exe, and you have to have the full system path before it. That must have something to do with setting path variables in your system or something. I'm not the best with command prompt. I've never used Linux. I'm not used to that. I use Windows, so I'm lucky that I was even able to produce those results and it worked. So anyways, yeah, we did it. Okay, copying boot sector to floppy disk. Okay. So we've got to take this and now we need to run part copy program to copy our new .bin file into our USB thumb drive by opening the command prompt and pasting in the following command. Okay, but we need the full path between each thing. So part copy will be the executable. That goes there. Boot.bin is going to be the next thing. the name of the file we want to copy, and then 0 space 200 0 space 200 space hyphen F space and then 0? No, there's no space after that. Okay. Alright, so partcopy.exe, the name of the bin file, the full path, and then 0 space 200 hyphen F0. Oh, by the way, note that the size of the resulting bin file must be 512 bytes, or else we screwed up the assembly somehow. Note that to paste the code, right click on the header of the window of command prompt and select edit from the drop down, and that will have a paste command within its menu. Okay. Oh, pcopy02. Okay. Full path. pcopy02, then partcopy.exe. All caps. Okay. Is it 512 bytes? 1 kilobyte. Wait! No! Is it because of all the notes we put in? Can we not put those notes in? Wait. Properties, did they just round up? No, it's 512 bytes. It's 512 bytes. Okay, we're good. But look at this. It says 1 kilobyte here, which is a lie. But they just rounded it up. So that scared the heck out of me. We're good. So all the notes we put in did not make the bin file bigger because this is compiled. So it took out all the notes because they're not relevant to a non-human reader. So it's going to be smaller than the file with all the notes in it. So that's exactly right. Okay. And I don't like it. Oh! What does all this mean? 0200 F0? Because I'm not doing it to a floppy disk. I'm trying to do it to a thumb drive. Maybe... Oh, it's so cool. He's gonna gradually make the bootloader cooler and cooler. Oh no. Booting process. Writing hello world. Bootloader. Programming floppy disk controller. What? No. Then what I need is wait. Doesn't he have like next section or something? Maybe it's on here? What is this? MS-DOS prompt? Hex view? Cool. Oh man. osdever.net /download/other/p copy02.zip part copy software. What? Well, we could leave 200, I guess. Means copy the first 200 bytes of the file. Blah 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 dot dat. Something 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 dot dat. Okay, we're gonna switch to this other one. Because his example looked super buggy with how he commanded that, and he's commanding it for F0. I don't know what that's gonna do. That could end up writing this bootloader onto one of my hard drives and completely destroy everything somehow and ruin all my data. That could be disastrous. I'm not playing around. Okay. I gotta be careful and use something that I trust. Okay. So we're using this DD program, which copies Linux's DD command for Windows though, and it has a really intuitive command thing that I actually understand. So we're getting rid of part copy entirely. Replacing it with this. Okay. Okay. So dd.exe, okay. Okay. Now we get this. Alright. So this is accurate, okay. OF equals, okay. Alright, let's just copy everything after OF equals.
Alright, and what's the drive letter of our USB?
E. If we got it wrong, it would be devastating. Oh, I'm scared. It will just overwrite gigabytes upon gigabytes of my files and destroy an entire partition if we mess this up. Oh my gosh. In file, my C drive, my files, boot.bin. F drive, desktop, dd-0.5, dd.exe. In file, C drive, my files, boot.bin. In file, boot.bin. Out file, OF equals backslash period backslash Z, which mine was E, and then colon. BS equals 512, count equals 1. Looks good. We went over it twice or 3 times. Where E is the drive letter of your mounted USB drive, IF is the input file, and OF is the output device, BS is the block size, and count is the number of blocks to copy. Okay, so that's my whole command. We're going to paste this in. Cannot access because it's being used by another process. What? That was weird. What process is using it? That's supposed to mean. Alright. I just unplugged it, replugged it in. Pasted the command again. Okay, looks like it did it maybe. Raw write DD for Windows version 0.5, written by John, blah blah blah. This program is covered by GPL. 1 plus 0 records in, 1 plus 0 records out. Okay. I think it means I did it. Oh. Whoa. It doesn't read it as a size anymore. What does that mean? Use space 0 bytes, free space 0 bytes. That looks wrong to me. Alright. What's going on here? ARPA robot os / boot.bin. I think it just confuses Windows. Maybe we did it right to begin with. Maybe. Because it would no longer be in Windows format if we truly overwrote. What if I tried this formatting? I want to see if it changes things. Alright, so it's DD. IF remains the same. OD equals Z colon. Except we want that to be E. Okay, all of these would just be the same. Let's see if it does the same. Let's try it. Oh. Okay, that one did not work. Uh... Used by another process again?
Alright, so Windows treats it as being corrupted. But we believe it's because it's not formatted by Windows now. But that a BIOS will understand it because it has our BIOS, it has our bootloader on it. That's the theory. If this doesn't work, I need to switch to floppy drive and follow the directions more carefully. I'm trying to switch floppy drive for USB to kind of to modernize the tutorial. Who has a floppy drive, right? So that's why I'm having to diverge. I don't even own a floppy drive. Who the heck owns a floppy drive in 2020? What the heck? It's insane to expect. Seriously, do any of you guys own a floppy drive? I might actually own one, now that I think about it. I think I have one in my junk drawer, but for crying out loud. If I do have one, I should have thrown it away. I'm surprised I didn't. Like, why would you keep that? Florida, you said you're a hoarder. You don't count. You don't count in this matter. Alright, entering setup. I had to press F2. My thumb drive is plugged in right here in the side. So it's taking forever. Okay, we want to tell it boot sequence. To move a device up, press U. Alright, we moved USB storage device to the top. We're going to press escape to exit setup. Save and exit. Okay, so now it's going to try to boot off the USB. Crap. Starting Windows. That means booting off the USB failed. Oh my gosh. Does this even have... This thing doesn't even have a floppy drive, so I couldn't use a laptop to do it with a floppy drive. I don't think that thing copied it right. Shoot. Let me see if I have a floppy drive. Alright guys, we're out of time for today. But I think I have to follow a tutorial for how to create a bootable USB drive. And I might have to convert the bootloader into an ISO first or something like that. And then convert that to a bootable USB or something like that. I have to change my workflow up. So we'll figure it out. We just need a lot more troubleshooting time, and I've ran out of time because I'm too tired to keep going. So we'll just have to come back to it. So peace out, guys.